When most people hear the word entropy, they picture mess, rooms getting cluttered, systems falling apart, order dissolving into chaos. It sounds negative, almost moral, as if the universe has a bad habit of letting things go. But that picture is misleading. Entropy is not the enemy of order. It's the cost of change. And once you see that clearly, your understanding of time, memory, and even meaning begins to shift. Richard Feynman was very careful about this point. He didn't like vague explanations, especially when they made people feel they understood something they actually didn't. Entropy, in its simplest and most honest form, is about probability. Systems move from less probable arrangements to more probable ones. Not because they want to, not because of decay or failure, but because there are overwhelmingly more ways for things to be spread out than neatly arranged. Now here's the crucial insight. If entropy didn't increase, nothing would happen. No cooling, no heating, no mixing, no aging, no thinking. A perfectly ordered universe would be frozen, not just physically but experientially. Time would have no direction because nothing would distinguish one moment from the next. Entropy isn't what ruins things. It's what allows events to unfold. Psychologically, this challenges a deep intuition we carry. We associate progress with control and permanence. We want things to stay fixed once they're right. But the universe doesn't work that way. Change requires imbalance. Movement requires gradients. Life itself depends on the ability to take energy from one place and disperse it elsewhere. Entropy is the bookkeeping that tracks that exchange. This is why time feels like it moves forward. Not because clocks tick, but because entropy increases. A glass shatters and doesn't reassemble. Heat flows from hot to cold, not the reverse. These aren't rules imposed by time. They're consequences of probability. And because these processes leave traces, we experience a past that feels solid and a future that feels open. Notice something subtle here. We don't experience time directly. We experience records, memories, photographs, scars, fossils, data. All of these are low-entropy structures created by energy being dissipated elsewhere. Every memory in your brain exists because entropy increased somewhere else in the system. Awareness itself rides on irreversibility. That's a startling thought. Consciousness depends on the very thing we often describe as decay. Without entropy, there would be no remembering, no learning, no sense of before and after. The flow of time is not a background feature of the universe. It's an emergent consequence of how matter and energy rearrange themselves. Philosophically, this reframes loss and impermanence. We tend to see irreversibility as tragic, but irreversibility is what gives moments weight. If everything could be undone perfectly, nothing would matter. Meaning arises because states are fleeting. Entropy doesn't erase value. It creates it by ensuring that experiences are unique and unrepeatable. Feynman had a way of making this feel less abstract. He would point out that you don't need to mystify entropy. You can see it in everyday life. The simple fact that you can remember breakfast but not tomorrow's lunch is not a limitation of imagination. It's a physical fact about how the universe stores information. The past exists because entropy allowed it to leave footprints. The future hasn't happened yet, so it hasn't scattered anything to record. So when we say entropy is the price of time moving forward, we're not making a poetic claim, we're stating a physical one. Forward motion, learning, evolution, and experience all require that price to be paid. And here's the reflection to carry with you. If entropy is what makes time real, then resisting change is not wisdom, it's denial. Understanding entropy doesn't teach you how to stop time. It teaches you how to live honestly inside it. Because once you see that change is not a flaw in reality but its engine, you stop fearing the flow and start using it. Once you grasp that entropy is the price paid for change, a deeper paradox comes into view, one that unsettles even seasoned thinkers. The fundamental laws of physics, the ones written down in equations, don't actually care which way time points. Run them forward or backward, and they still work. Nothing in Newton's laws or even in much of modern physics insists on a preferred direction of time. And yet, your life only moves one way. You remember yesterday, not tomorrow. You grow older, not younger. Something, somewhere, is breaking the symmetry. This is where entropy quietly takes control. Richard Feynman loved this contradiction because it exposed the difference between mathematical description and lived reality. The equations describe what can happen. Entropy describes what will happen. Physics allows reversibility, probability forbids it in practice, and reality follows probability every time. Imagine filming a simple event, a cup falling off a table and shattering. Play the film backward. Nothing in the laws of motion forbids that reversed sequence. Atoms could, in principle, reassemble. Energy could flow back into organized motion. But we never see it. Not because it's illegal, but because it's absurdly improbable. There are vastly more ways for pieces to be scattered than assembled. Entropy stacks the odds so overwhelmingly that the universe behaves as if time has a direction, even though the rules themselves don't demand one. Psychologically, this creates a powerful illusion. We feel time as something fundamental, something baked into reality. But what we're actually feeling is the one-way accumulation of irreversible changes. We mistake consequence for cause. Time doesn't push entropy forward, entropy gives time its arrow. This distinction matters because it strips away comforting narratives. There is no cosmic clock forcing events to unfold in sequence. There is no hidden engine driving time forward. There is only probability, unfolding relentlessly, shaping which histories survive and which fade into impossibility. And this has a profound implication. The past and the future are not treated differently by the laws of physics, but they are treated differently by entropy. The past is a record-rich region of reality. The future is record-poor. That's why the past feels fixed and the future feels open. It's not metaphysics, it's bookkeeping. Every time entropy increases, information about the previous state is smeared out, distributed across the environment. That's what makes processes irreversible. You can't reconstruct the exact past because the information required has been diluted into countless microscopic details. The universe hasn't erased the past, it has made it inaccessible. Philosophically, this forces humility. The sense of control we associate with planning, prediction, and explanation is local and temporary. We surf on a narrow band of low-entropy conditions, calling it now, while everything else dissolves into statistical fog. Time's direction is not guaranteed. It's borrowed. This also reframes regret and nostalgia. We often we could go back, undo, reverse. Physics doesn't forbid it. Entropy does. The universe is not cruel for refusing reversal, it is simply indifferent. The arrow of time is not a moral judgment, it's a statistical outcome. Feynman's brilliance was in refusing to romanticize this. He didn't see entropy as a tragic limitation, he saw it as clarity. It tells us exactly why certain questions, like why can't we go back, have answers that are not emotional or philosophical, but mathematical. The universe is not conspiring against us, it's just counting possibilities. And here's the reflection worth sitting with. If the laws of physics are neutral about time, but your experience isn't, then your sense of direction comes from irreversibility, not destiny. Meaning doesn't come from where time is going, it comes from the fact that it doesn't turn around. So instead of asking why time moves forward, ask what you are doing with the one direction you're given, because entropy won't let you rewind, but it will let you choose how clearly you move ahead. At this point, a strange question naturally arises. If the laws of physics don't privilege the past over the future, and if entropy is what gives time its direction, then why does the past feel so solid? Why does it feel like something that exists, while the future feels vague, unreal, almost imaginary? This is not just a philosophical puzzle, it's a deeply physical one. Richard Feynman approached this question with a kind of blunt honesty that had made people uncomfortable. He pointed out that the past feels real for a very simple reason. It left evidence. The future hasn't. And that difference has nothing to do with fate, destiny, or metaphysics. It has everything to do with entropy and information. Every moment that passes leaves traces, footprints in sand, photons bouncing off objects and traveling outward, neurons changing their connections in your brain. These are not abstract memories, they are physical records. And every one of those records exists because entropy increased somewhere else. Energy was dissipated, order was spread out, and information about what happened got embedded into the present state of the universe. That's why the past feels fixed. It's written into countless arrangements of matter and energy. Your memories, history books, fossils, data files, even the scars on your body, these are all present-day structures that encode past events. The past doesn't feel real because it exists back there. It feels real because it exists right now as evidence. The future, by contrast, has left no records. There are no physical traces of tomorrow, because nothing has happened yet to scatter information into the world. From a physics standpoint, the future is not a place waiting to arrive. It's a set of possible configurations that have not yet been selected by entropy. That's why it feels open. Not because it's unreal, but because it's undetermined. Psychologically, this creates a powerful illusion. We feel like we're moving through time, leaving the past behind us. But what's actually happening is that the universe is constantly reconfiguring itself, and some configurations carry information about earlier ones. We live inside those records, so the past feels solid. The future lacks records, so it feels empty. This also explains why prediction is so different from memory. You can remember with great detail, but you can only predict statistically. Memory is anchored in physical evidence. Prediction is anchored in probability, and probability is never certain. That asymmetry is not a flaw in human thinking. It's a feature of the universe. There's something quietly unsettling about this. It means the past doesn't exist in the way we imagine. It isn't stored in a cosmic archive. It survives only insofar as the present still carries its imprint. If every record were erased, every memory, every document, every physical trace, the past would not be recoverable. Not because it didn't happen, but because entropy would have erased its fingerprints. Philosophically, this reframes nostalgia and regret. We often think of the past as something we could revisit if only we had access. Physics says otherwise. The past is not hidden, it's gone, except for what it managed to leave behind. What you call the past is actually a special pattern in the present. And here's the deeper implication. Your sense of identity depends on entropy. You feel like a continuous self because your brain preserves records of prior states. Without that irreversibility, consciousness itself would dissolve into a sequence of disconnected moments. Awareness requires a past that can be remembered and a future that cannot. Feynman never tried to make this comforting. He made it clear. The universe does not preserve moments because they matter. Moments matter because they cannot be preserved. So when the past feels heavy and the future feels unreal, remember what's actually happening. You are standing inside the evidence of what is already scattered, while facing a horizon that has not yet left a trace. And the reflection worth carrying forward is this. If the past feels real only because it left records, then the most meaningful thing you can do is decide what kind of evidence this moment will leave behind, because that is the only way the future will ever know you were here. If the past feels real because it left evidence, the next step is unsettling, but unavoidable. There is no vault in the universe where the past is stored, no hidden timeline running alongside the present, no cosmic hard drive preserving yesterday in its original form. What we call the past is not a place. It is a pattern that survives only insofar as it is written into what exists now. Richard Feynman was very clear about this, even though people often resist the implication. Physics does not describe the past as something that continues to exist independently. It describes the present state of the universe. And that state may contain records of earlier states, that's all. Once those records are gone, the past is gone with them. Not hidden, not waiting, gone. This is difficult to accept, because our intuition treats time like space. We imagine the past is back there, the future is up ahead, and ourselves moving through a timeline. But that picture is a psychological convenience, not a physical reality. In physics, only the present configuration exists. Everything else survives only as information encoded within it. Think about what a record actually is. A photograph is not the past. It's ink or pixels arranged in a certain way now. A memory is not a replay of yesterday. It's a physical change in neural connections now. Even light from distant stars is not the past floating through space. It's electromagnetic radiation arriving and interacting with detectors now. The past does not persist. Its evidence does. Entropy is the gatekeeper here. Records require low-entropy structures. They are fragile. They fade, decay, get overwritten, or disperse. As entropy increases, information spreads out and becomes inaccessible. That's why memories blur, documents degrade, and civilizations vanish. Not because time is cruel, but because probability erases fine detail. Psychologically, this realization can feel disturbing. We often anchor our identity in the idea that our past is safely stored somewhere, that who we were is permanently real. Physics offers no such comfort. The only reason your past feels stable is because enough records still exist to support that story. Change the records, and the story changes with them. This also explains why history is never as solid as we want it to be. We argue about what happened because the evidence is incomplete. The universe does not preserve truth for us. It preserves traces, and only temporarily. Certainty fades not because reality is subjective, but because information is perishable. Philosophically, this forces a radical shift in how we think about existence. The past is not a thing you possess. It is something you left behind. It survives only if the present still carries its imprint, and that means clinging to the past as if it were permanent is a category error. Permanence was never on offer. Feynman never softened this conclusion. He didn't believe physics existed to make us feel better. He believed it existed to tell us how things actually work. And what it tells us here is stark. The universe does not remember for us. It only rearranges itself. And sometimes those rearrangements contain clues. But there is a quiet empowerment hidden in this idea. If the past survives only as evidence in the present, then your actions matter not because they echo forever, but because they shape what remains now. Meaning is not guaranteed by duration. It is created by impact. Every conversation, every choice, every act of attention leaves some trace. Most will fade, a few will persist longer, none are eternal. And that is not tra. It is precise. It tells you exactly where responsibility lives, not in preserving the past, but in shaping the present. So here is the thought to carry with you. If the past does not exist anywhere except in what survives, then stop living as if it owns you. Learn from the records it left, but don't mistake them for chains, because the universe is not asking you to remember forever. It is asking you to decide what evidence you are creating right now, before entropy carries it forward and lets the rest dissolve. Now we arrive at something deeply personal, because entropy is no longer just an abstract principle about heat or probability. It reaches directly into your mind. The reason you can remember yesterday but not tomorrow is not psychological coincidence or biological accident. It's a physical constraint. Memory itself is an entropy-driven process. Richard Feynman made this point in a way that startled people. Remembering is not free. Every act of memory formation requires energy, and every bit of information stored in your brain increases entropy somewhere else. Thought, awareness, learning, these are not outside physics. They are consequences of it. When you remember something, your brain is not reaching backward through time. It is rearranging matter in the present. Neurons change their connections. Chemical gradients shift. Heat is released. Information is written into a physical system, and that writing process is irreversible. You cannot remember without increasing. Entropy. That's why memory only points one way. This is why the future is fundamentally unrememberable. Not because it hasn't happened in a poetic sense, but because there are no physical records yet to retrieve. Memory is not imagination, it is access to evidence, and evidence only exists after entropy has done its work. Psychologically, this explains something subtle but profound. We experience consciousness as a moving window with a trailing wake. The wake is memory, the window is awareness, and the wake can only exist because the universe allows irreversible changes. Without entropy, consciousness would collapse into a timeless blur, no before, no after, no self. This also explains why trauma, learning, and identity feel so real. They are not abstract impressions, they are physical imprints. Your past is literally written into the structure of your brain. And because those structures required entropy to form, they cannot simply be undone. Forgetting is not reversal, it is further rewriting. There's a philosophical weight to this. You are not just living in time, you are built by it. Every memory you carry is proof that entropy has already increased. Your sense of self is a low-entropy pattern temporarily resisting dissolution. That resistance gives you continuity. But it is not permanent. Feynman never treated this as depressing. He treated it as clarifying. It tells us why awareness is precious. Consciousness exists only because the universe is not reversible. If you could remember the future as easily as the past, choice would be meaningless. Decision requires asymmetry. Meaning requires one-way change. This also reframes regret. We often wish we could unremember, go back, or erase. Physics says no. Not because it's cruel, but because the same rule that allows learning forbids undoing. The universe doesn't selectively preserve what's convenient. It preserves what probability allows. And here's the deeper insight. Since memory is physical, attention matters. What you repeatedly attend to gets written more deeply. You are, quite literally, shaping the entropy profile of your own mind. What you practice becomes structure. What you ignore fades. So awareness carries responsibility. You cannot control entropy, but you can decide where it leaves its marks. You cannot remember tomorrow, but you can decide what today will be worth remembering. And that leads to a powerful realization. If memory only flows one way, then living well is not about holding on. It's about choosing carefully what you allow to be written into you. Because the universe will not let you remember the future, but it will make you live with the evidence you create now. At the end of all this, the temptation is to ask the biggest question of all. If entropy defines the arrow of time, if the past leaves traces and the future does not, then does the past still exist in any meaningful way, or is it gone forever, dissolved into probability? Richard Feynman approached this quest with a kind of disciplined humility. He never pretended physics could answer everything, but he was very clear about what it does say. From the standpoint of fundamental laws, the past is not sitting somewhere intact, waiting to be revisited. What exists are records, scattered, imperfect, physical records embedded in the present. Fossils, photographs, memories, radiation patterns, neural connections. The past survives only as evidence, not as a place. This matters psychologically more than we usually admit. We talk about living in the past, as if the past were a room we keep walking back into. But physics tells a different story. You are not returning to the past. You are consulting records that exist now. Every time you recall a memory, you are not opening a vault. You are reconstructing a pattern using present-day matter and energy. And that reconstruction itself changes the record slightly. Even memory is subject to entropy. This explains why certainty about the past fades over time. Not because truth disappears, but because records degrade. Entropy does not just push systems forward, it blurs them. The further back you go, the fewer reliable traces remain. That's why history becomes probabilistic. That's why ancient events are inferred, not observed. The past doesn't vanish, it becomes noisy. There's something unsettling here, but also freeing. If the past only exists as records, then it does not have absolute authority over the present. It influences you, yes, but only through what remains. And what remains is never complete. This is why change is possible. If the past were fully present, fully preserved, nothing new could emerge. From a philosophical perspective, this dismantles fatalism. The arrow of time does not imprison you, it creates the conditions for novelty. The future is open precisely because it is unrecorded. No evidence exists yet to constrain it. That uncertainty is not a flaw in reality. It is its most essential feature. Feynman loved this idea because it aligned with how science actually works. We don't discover final answers, we reduce uncertainty. We don't access the past directly, we infer it. And we don't predict the future with certainty, we calculate probabilities. Entropy doesn't remove meaning. It defines the arena in which meaning can exist. Now bring this down to the human level. Anxiety often comes from trying to treat the future like the past, demanding certainty where none can exist. Regret comes from treating the past like the future, imagining it could still be changed. Both are misunderstandings of time. Peace comes from respecting the direction things actually move. This doesn't mean resignation. It means alignment. You act knowing that what you do will become a record. Your words, choices, and habits will harden into evidence. You are constantly manufacturing the past of tomorrow. And while you cannot control entropy, you can decide what patterns you create before it locks them in. So the question is no longer, does the past still exist? The better question is, what kind of past are you creating right now? Because one day, all that will remain of this moment are traces. Some in the world, some in other people, some in you. And those traces will shape what comes next. You cannot step outside time, but you can choose how honestly, how courageously, and how consciously you move forward with it. And that may be the most practical lesson entropy has to offer. The future is OP. And the past is written, and the present is the only place where meaning can still be formed.